Hello, my name is Brandon Green, and this is my dimensional modeling presentation. Four-step dimensional design process. Select the business process. I will choose retail since I have chosen Goodwill Industries for my last presentation. I've decided to go with the retail since there are many pressing business questions. Declare the grain. I will now choose the details I want to apply to the dimensional model. This can be informational on sales or the number of sales of certain items. There is a lot of information you can use in retail, especially when there is more than one store. Identify the dimensions. I will use the grain statement to determine the primary dimensions. The dimensions include date dimension, store dimension, point of sale, retail sales, transaction fact, product dimension, and promotion dimension. Identify the facts. I will now choose business measurements for the fact table. The facts will be collected by the point of sale system: sales quality, sales price, sales amount, and standard cost. Here we have the four-step dimensional design process image. As you can see, we have the items, the dimensions, and then in the circle that's connected with everything, it's the retail shopper empowerment. So under items where it says 5 items, we have retail environment. 2 items is store convenience. 4 items is relevant communication. 3 items, expansion and control over choice set. Business fact tables. I will handle business fact tables by using the transactional fact table. This is the most basic fact table and works as one row per line in transaction. Utilizing this fact table, I will be able to take certain data that is needed. For this fact table, we have store dimensions, customer dimensions, time dimension, and product dimension. They are all connected to the fact table. OLAP cubes and alternatives. Online analytical processing supplements cluster analysis and is fast and effective. OLAP represents class software that can enable decision support and can report based upon a warehouse. OLAP cubes are numbers of data dimensions and may have fewer than 3 dimensions. OLAP cubes are constructed from the fact table and the dimensional table. So as we can see in our image, the operational experimental data is the first one starting off. That leads to extraction, transformation loading, which goes down and over to data warehouse storage. Data warehouse storage goes up to OLAP, which is online analytical processing. And then from OLAP, we go to user analysis. Now we're going to get into EDM schemas. Both star and snowflake schemas are almost similar to each other. The only difference is in the dimensions themselves. Star schemas' logical dimensions are denormalized into a single table. With snowflake, only some of the dimensions are normalized. I have to say Snowflake is more efficient with database space when dimensions have many large text fields. We're going to go to the star schema image. For the star, the table is like a star. So it's easy to tell the difference between the two. But you have the dimension table, you have the fact table. Each one has something different. So the first one in the top left has dealer. Below that is branch dim. In the middle we have revenue. The top right is date, and the bottom is product. And as for Snowflake, Snowflake is actually, it's just like a snowflake. Um, Once again, you can tell the difference between the two. We still have the dimension tables. We have location, country, dealer, branch, revenue, date, product, and variant. That will be it for my presentation. I hope you enjoyed, and thank you.